Is left-handedness hereditary? What determines whether a child will be left-handed or right-handed? Is it determined more by genes or by the environment? We will try to answer these and similar questions in today's episode of the series Secrets of Genes, in which I welcome you. My name is Edward Kejnowski, and I work as a geneticist at the Institute of Biophysics of the Czech Academy of Sciences. When we pick up a pencil, few people think about why it's in the right hand or the left. Yet this is a visible manifestation of a deeper property of the brain called laterality, meaning how our hemispheres divide up their work. In most people, speech and fine motor skills are controlled by the left hemisphere, which is why the right hand is dominant. In left-handed people, the brain map is more varied. Sometimes it's a mirror image, other times it's mixed. And this is exactly where the genetic story begins. Left-handedness is not inherited through a single gene. There is no left-handed, right-handed switch. It is a polygenic trait influenced by many genes and developmental factors. These genes do not determine which hand you use, but rather how the left-right axis of the body is set during embryonic development, and especially the asymmetry of the brain. Already in the first weeks of development, it is decided where the heart and liver will be, and at the same time, the asymmetry of the nervous system is being very delicately shaped. Handedness is thus somewhat of a byproduct of how the brain draws its internal map. Genetic studies have found dozens of locations in the genome that are related to handedness. Genes such as LRRTM1, which influences the formation of synapses, PCSK6, involved in determining the left-right axis of the embryo, or DCDC2, which controls the migration of neurons in the cerebral cortex, are often mentioned. Genes for the cytoskeleton of neurons, such as TUBA1B or MAP2, are also important. They all have one thing in common. They don't build the hand, but rather the architecture of the brain, where dominance is only decided later. That's why heredity works only in terms of probability. If both parents are right-handed, a left-handed child is born in about 8 to 10% of cases. If one parent is left-handed, the chance rises to about 20%. And if both parents are left-handed, it can go up to about 30 to 40%. So the genes don't say you will be left-handed, but rather you might lean to the left. On top of that, the environment in the womb also comes into play. The position of the fetus, blood flow to the brain, slight differences in oxygen and hormone levels. There is a hypothesis that higher prenatal testosterone may slightly slow the development of the left hemisphere and give more space to the right, which increases the chance of left-handedness. In short, the brain doesn't decide according to a precise plan, but rather through a process. A beautiful proof of the role of chance is identical twins. They have the same DNA, the same genome, and yet about a fifth of them differ in handedness. If it were only about genes, they would be the same. The difference arises in the subtle details of brain development even before birth. It's also interesting that left-handers have never disappeared. Evolution hasn't eliminated them. A minority strategy can actually be advantageous in fighting, sports, music, and creativity. Unpredictability has biological value. Left-handedness thus increases the diversity of the species and reminds us that the brain doesn't have just one correct solution. So left-handedness represents a biological variation that increases the diversity of the species. Until recently, left-handed people were retrained to use their right hand. Today, we know that this doesn't rewrite a person's genetics or brain. It only forces the nervous system to work against its own nature. Handedness is not a habit. It's an imprint of brain development. So when someone picks up a pencil with their left hand today, they're not just doing it on a whim. There's a genetic blueprint in it, embryonic improvisation, hormonal tuning, and a bit of chance. The brain tilts, and with it, the whole world either to the right or to the left. That's all for today. We've talked about a few interesting facts from genetics, specifically about how left-handedness and right-handedness work. In the next episode, we'll continue with more interesting questions from genetics and evolution. I'm looking forward to seeing you. If you enjoy my storytelling, I'd be grateful for a like and for subscribing to my channel. I really appreciate your support. Thank you and bye-bye.